So let's talk about quotients. Right? So we're seeing that there's value in taking the derivative, that the derivative is going to tell us important things about real-life applications. Derivatives are going to tell me something about being able to accurately estimate values that I'm interested in. It's also going to tell me how to maximize or minimize values that I'm interested in maximizing or minimizing, right? How do I minimize average cost? How do I maximize profit? As a business owner, those are things that I'm really going to be interested in. So derivatives, super useful. I want to be able to take derivatives of as many things as possible. So, we know u prime and v prime. That says we know, sorry. We know u prime and v prime. So if I wanted to take the derivative of their sum, that's super easy. If I want to take the derivative of their difference, that's also super easy. Okay. We found last time, though, that the derivative of their product is much more complicated. Right? But it can be done, and it follows a pattern. The derivative of u times v is u prime v plus u v prime. Remember that every factor has its derivative taken, and then you sum up all of the products that result. You will note in particular that it is not u prime v prime. Right? That is not something that we will do. Right? You can't just take the derivative of the first one and the derivative of the second one and be done. It has to follow this pattern. Before we get out of here today, I want to do this guy. What if I have u divided by v? I will spoil it for you immediately and tell you that it is not u prime over v prime. No, that's not true. It's impossible.
So u prime v divided by v prime u?
No.
V subtract.
There's going to be all kinds of crazy stuff. All right. I am not going to go through the hassle that you all are surely just going to kind of like get glassy-eyed with and tell you why this works the way that it does. Right? I did it for sums and I did it for products. I'm not going to do it for quotients. I'm just going to kind of spoil the surprise. The derivative of u over v is v u prime minus u v prime divided by v squared. Gross, right? There are a couple of ways that you might try to remember this, and you will definitely want to have this memorized. If you want to use this UV notation, you'll notice that the whole thing has a V kind of shape to it, and the V's are then on the outside, right? There's a V in the denominator, and a V comes first in the top, and a V comes last in the top. You'll notice that also that the difference that's in the numerator, it's VU prime minus UV prime. Notice that just like the product rule, only one part of the function is having its derivative taken at any one time. And because of the way that I've written it, it's always the second one, right? It's VU prime minus UV prime. So, and the V's go on the outside, so the order is definitely going to matter. And then it's V squared in the bottom.
Does the order matter for the product?
The order does not matter for the product. I've written it this way in order to make it easy to memorize for this kind of V mnemonic device. This is not my preferred mnemonic device. My preferred mnemonic device is this. low d high minus high d low over the square of what's below. It's a nice little poem. It's horrible. However, it could be worse. I've heard so many horrible versions of this. People will say like, oh, it's low d high minus high d low over low low. There's no meter to that, right? You need the syllables, right? Low d high minus high d low over the square of what's below. It's got symmetry to it, and it rhymes. Right? Other people will say low d high minus high d low over the bottom squared. Doesn't rhyme. Horrible. I don't know. There's psychopaths, right? Yeah. There's artistry here, right? So how do I make sense of this? Why is this telling me this? All right. So low means the bottom function. D means the derivative of, right? Or like this d dx means the derivative of. And high means the top function. So low d high means the bottom function times the derivative of the top function minus high d low. So the top function times the derivative of the bottom function. Low is the bottom function. And then over the square of what's below. What's below, again, that's the bottom function, and it's squared. This is called the quotient rule. It is how we take derivatives of quotients. Let's see it in action on something that we already know the derivative of. Yeah? So I'm going to leave this at the top of the page. And as an example, let's do 1 over x. I said we already know the derivative of this. How do I know the derivative of this? Yeah, it's a power, right? There's a secret power here. This is x to the negative 1. Right? So y prime should be negative x to the negative 2, which is negative 1 over x squared. So if I can write this as a power, then I can just use the power rule, and I know the derivative. Okay? But just to kind of assure ourselves that we're doing the right thing here, let's see the quotient rule in action. All right. So y prime is low. That's the bottom. D high. So the derivative of the top. What's the derivative of the top? The derivative of 1 is 0. It's a constant. So x times 0 minus high, that's 1. D low. What's the derivative of x? 1. Divided by, right, so over the square of what's below. What's below is x, and it's going to get squared. So that's x times 0, which is 0, minus 1, so negative 1, over x squared. Negative 1 over x squared. Works great. So it works on this thing that I already know. You want to see it on something that we don't know? Right? All right, that's fun. F of x is equal to e to the x divided by the square root of x. So this is interesting because there is no way that I would have been able to take care of this before, right? It's this mixture of an exponential function and a power function, and they're being divided by one another, and there's no way for me to mush these two things together or to simplify this expression so that I'm adding things, which I like, or taking a difference of things, which I like. I'm not going to be able to pull these two functions apart. They're just going to be tied together. I might have been able to do it using the product rule, but so let's ignore that for the moment. Yeah. So what's happening? F prime, right, is low, square root of x. D high, what's D high? e to the x. The derivative of e to the x is just e to the x. Minus high. Great. D low. Ugh. Low is x to the 1/2. So d low is 1/2 x to the negative 1/2. I got to use the power rule. You may remember that as 1 over 2 root x. D low sounds like a rapper from the 90s. Skilo's little brother. Anybody remember Skilo? He wished he was a little bit taller.
Was he a baller?
He wished he was.
There you go.
He wished he had a rabbit in a hat. All right. Anyway, so d low, d high minus high, d low. All right, so d low over the square of what's below. So root x squared. Root x squared I like because that's really easy to do. But I have this root x here that's in a denominator. I've got fractions inside of fractions, which I'm not a huge fan of. But there's kind of a standard way for me to get rid of those. I can multiply by the denominator, and when I distribute it through, it's going to get rid of everything. So I can rationalize, I say rationalize, I can simplify this to get rid of denominators inside of this fraction by distributing this through. And we get something like 2x e to the x minus e to the x, all divided by 2x root x. Sure. That seems like a fine way to write it. And I don't have fractions inside of fractions anymore. Right. But really, once I'm here, I've done all the hard work. Right? This dotted circle encapsulates what the answer is specifically. Right? I just don't like the way it looks. It's not as pretty as it could be. It's got fractions inside of fractions. Who wants to look at that all day? Not me. Okay.
For that 1 divided by 2 square root of x, is that the same as 1/2 x to the negative 1/2 power?
It is. Yeah, it is. Yeah, I pulled it from here. Okay. This got really sloppy really fast, but I'm kind of crowded at the bottom of the page here, so my apologies. Okay. But really, the quotient rule is just kind of us finding what the top is, what the bottom is, and punching it into the pattern. Right? Low d high minus high d low over the square of what's below. If you're saying it to yourself and it's not rhyming, then you're doing it wrong. Somebody will do high d low minus low d high. But high doesn't rhyme with low. So when you say over the square of what's below, you'd think, oh, wait, I'm an idiot. High doesn't rhyme with low. And you would go back and you say, all right, low d high minus high d low. That's the way it goes. It's going to have the lows at the end. Anyway, I don't care how you memorize it, just that you do. I did say that we might have been able to tackle this using the product rule, so I want to do that because I much prefer that to the quotient rule. This is the square root of x in the denominator. What if I just brought that up to the top so that I didn't have a quotient? Instead, I had a product. This is e to the x times x to the negative 1/2. Now, instead of having to use the quotient rule, I can use the product rule, which is a little bit easier. Right? So y prime is the derivative of the first, and then I'll leave the second alone, plus the first left alone times the derivative of the second one. So negative 1/2 x to the negative 3/2. And I got here a lot faster. I still have these negative exponents that I might like to get rid of. That's e to the x over root x minus e to the x over 2x to the 3/2. But if I find a common denominator here and simplify, I'm going to get exactly what I got before. I'm going to get 2x e to the x minus e to the x, all divided by 2x root x, or x to the 3 halves. X times the square root of x is x to the 3 halves. So if you wanted to find a common denominator, you could smush it all together. And it's the same as what we got before. Okay. So I like this idea. I like product rule a lot more than I like quotient rule in general, because quotient rule, it just creates a lot of havoc. There's going to be a lot of algebra for me to have to kind of struggle through some of the time, whereas the product rule can be just a little bit more straightforward. I don't have to memorize a poem of any kind, so that's nice. The problem we have right now, though, that will kind of let us kind of peek ahead into our future, is that this might not always be possible, right? I might have a situation like this. 2x divided by x squared plus 1. And I could bring this up, right? That's 2x times the quantity x squared plus 1 raised to the negative first power. But right now, I don't know how to differentiate that. This is a composite function. I had something to the negative first, and then I shoved a bunch of stuff in there. And I don't like having a bunch of stuff to the negative first. I'd much rather have like a single thing to the negative first if I'm going to take the derivative. So I could try to make it a product rule, but right now I don't know how to take the derivative of this second factor. And that is something that we can talk about next week.